Hello, geometry students. So we're continuing our study on how to prove triangles are congruent. Remember that if you want to prove any other polygons are congruent, you have to show every corresponding side's congruent and every corresponding angle's congruent. You have to show all those things, but we have some shortcuts with triangle congruency. Remember last time we talked about the side, side, side. If you can show three sides in one triangle are congruent to three sides in another, that is one of our shortcuts that allows us to prove that triangles are congruent. Today we'll learn a second shortcut. Now you have to look at the word included. Included means right in between. So the side, angle, side allows us to prove two triangles are congruent, but you have to be so careful about where that angle's placed. The only way you can use SAS, or SAS as I like to call her, is the side, angle, side, side, angle, side. The angle has to be included or right in between the two sides you're talking about. The angle has to be included or right between the two sides you're talking about. It's the only way you can pull out your SAS, your SAS. So if two sides and the included angle of one triangle are all congruent to the two sides and the included angle in another triangle, then that's all you need. That's your shortcut. And you can now state those triangles are congruent. So we'll practice both SSS and SAS in these problems. If you think you're ready, then pause and practice on your own paper. Remember, you can get given information in a statement, and also you can get given information on your diagram. In this particular example, there is no statement. All of our given information is on our diagram. Notice we're given that AC is congruent to CE with these scratch marks, and BC is congruent to DC with these scratch marks. So the next thing we can say is, what are we given? And we can jot that down. That is what we're given based on those scratch marks. And the next thing we can ask ourselves is what else do we know? Well, we know that vertical angles are always congruent. So we can jot that mark down too. And notice here I have a one scratch side included angle and a two scratch side in this triangle. And in the other triangle, I've got a one scratch side included angle and a two scratch side. So we can ask ourselves, is this enough information to prove triangle congruency? Yes, it is. By side, angle, side, we can now use this as our shortcut to write our congruency statement. Remember when you write your congruency statement that you have to line everything up just as it matches to its corresponding part. So A, B, C goes unmarked to 1. So here we have to do unmarked to 1. EDC. So now pause and try on your own paper and then press play for the solution. The first thing we have to look at is ask ourselves, what are we given? We're given measurements are the same, and we're given that these two segments bisect each other. So what does the given information tell us? There are two different bits of given information, and they each tell us something else. The fact that we're given measurements are the same, we can use our definition of congruency to know that these sides are then going to be congruent. And because of the definition of bisector, a bisector is something that cuts something else into two congruent parts, and since they bisect each other, they both get bisected. Therefore, now we know this. So because we're given measurements are congruent, we know definition of congruency. And because we know we're given bisectors, we know definition of segment bisectors tells us this. So now we know one scratch, two scratch, three scratch over here, one scratch, two scratch, three scratch over here. And we can ask ourselves, is this enough to prove the triangles are congruent? Yes, by side, 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 we can now write our congruency statement. RSV, triangle RSV, is congruent to triangle UTV. Pause, practice on your own paper, and then press play. So remember, we can be given the information in a statement or marks on the diagram. Here we're given both. So we're given G is the midpoint of EJ, and we're also given these marks. And so the first thing you want to ask yourself is, what are you given? What are you given? And you can jot that down. And so these are the marks we're given, and we're given this information. So first of all, what are you given? You want to jot that down. We're given angle E and angle J are congruent, and we're given that these sides are congruent. EF and HJ are congruent. Then you want to ask yourself, what does the given information tell us? We were also given that G is the midpoint of EJ. And so we're going to use our definition of midpoint here. And we jot that down, what that tells us. So because we're given G is the midpoint of EJ, then we know a midpoint divides a segment into two congruent parts. So now we know EG is congruent to GJ. And now we pause and we ask ourselves, is this enough to prove triangle congruency? We have one scratch, included angle, two scratch over here, being exactly congruent to one scratch, included angle, two scratch over here. And so yes, it is enough. We can use SAS, pull out our SAS, to prove that these two triangles are congruent. Triangle EFG is congruent to triangle JHG. So now you have two shortcuts to prove triangles are congruent. And I will leave you with these cute kittens and wish you a great day.